All right, hey gang, going to try to work through these problems here from our bonus opportunity at the end of the third quarter. Again, I want you to feel free to not only I want you to take notes on your test or your review packet that I'm giving back to you. I want to make sure you understand all parts that you didn't understand originally. But not only that, I would have a second sheet of paper that kind of just summarizes any parts that you are not familiar with, okay? And then, just hey, finish it up, make sure you understand those, and we're going to give our best effort come in a week or so on the actual air test. So here's what I have. Two triangles are similar. What do we know about similar triangles? Well, I'd probably write these two things down. Similar triangles, okay? We have congruent, corresponding sides, no, corresponding angles, sorry, corresponding angles. And then I would put down proportional corresponding sides. Okay, so basically the sides grow at the same rate, the angles stay the same measure. So the two triangles are similar, and if this helps out, angle A is congruent to angle J, angle B is congruent to angle K, and then angle L is congruent to angle C. Okay, so B is congruent to K, J is K. Now, what is the length of JL? Well, I can go ahead and match up some corresponding sides here. Like, for example, the longest side, 5, corresponds with 15. Okay, and that has to be growing at the same rate as 2.5 AC corresponds with JL. Okay, and so as a result, I might say 2.5 is to X or JL, or maybe I'll just make a question mark here because that's what it shows up in the problem as. Okay, and then you just cross multiply and solve. Okay, so if I do that, here you have 5 times the question mark is equal to 15 times 2.5, which ends up being 37.5. Okay, and then from there, if you divide both sides by 5, you get the question mark to be 7.5. Okay, simple problem. If you remember those two characteristics, corresponding sides are congruent, corresponding angles, I said that wrong, corresponding sides are proportional, corresponding angles are congruent. Okay, don't mix those two up on the test. Now, looking at this next problem here, looks like a proof of some sort. So we have in the quadrilateral ABCD, we know that AB is congruent to CD. That's been marked congruent already with those two. Okay. You have BC is congruent to AD, which would be those two. Okay. And then the triangles are congruent. So by the blank property of congruence, we can show that, well, what isn't proven congruent up here? It's that AC is congruent to AC. What property is that? That's the reflexive property. Remember, A equals A. It's the one that all of you enjoy doing because it's really simple and straightforward. That would then prove the triangles are congruent by side, side, side. Okay. As I said before, you don't have to get all the problems correct on the geometry air test, but you do need to get the ones that you know correct. This is a simple problem right here, guys. Take your time. Make sure you can get that problem right. Okay. Triangle XYZ is shown. Which triangle must be similar to triangle XYZ? Remember, the corresponding angles have to be congruent. So here's what I'm thinking. If I go ahead and add these two angles up, that gives me 140. The last angle has to be 40 degrees. What's that tell me? The triangle has to be isosceles because remember, when the base angles are congruent, the sides opposite have to be congruent. So, yeah, I'm thinking D right now. An isosceles triangle with only one angle that measures 40 degrees. Oh, I take that back because that could be the vertex angle. Let's go ahead and do this one right here. A triangle with two angles that measure 40 degrees, which would then make it an isosceles triangle. Okay. But if you have two 40-degree angles, we can easily find the last one by taking those two from 180, and then you would know the triangles are similar to each other. Okay. You would know the growth rate to get from one triangle to the other, but you would note they are similar. The next one, the coordinates of the vertices of triangle PQR are given. P is at negative 4, 1. 1, 2, 3, 4, 1. Okay, there's P, 2, 9 is here, and 8, 1 is right here. P, Q, and R. Okay. We want to find the perimeter of this triangle. Okay. Now, there are several ways you can do the perimeter. First of all, perimeter is to add up all sides. Okay. This length is really easy because it's horizontal. I can just count it. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that length is 12. And if you drop a line, you can do their distance formula for these two. Remember, the distance formula is shown on your formula sheet. But if I drop this line down right here, I know that this length is 1, 2, 3, 4, 5, 6. Makes that one 6 as well. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so basically, these two triangles are congruent to each other by side angle side. So all I need to do is find one of these side lengths, and then the other side length will be the same. Now again, you can do your Pythagorean theorem here. I'll make this C to solve for that length. 36 plus 64 makes 100. What is the square root of 100? It's just 10. Okay. But you could also do this. This is a 3, 4, 5 factor of 2. We're multiplying both sides by 2. 3, 4, 5 right triangle. So again, the perimeter, going back to this, we want to find the perimeter. One side was 12 and the other two were 10. Okay, so in the end, 32 is our perimeter, 32 units there. Okay, so again, use your Pythagorean theorem or your distance formula to get the third side length of that triangle. Okay. Isosceles triangle JKL has a perimeter of 32 units and given vertices at J, negative 3, negative 9. Okay, K is at negative 3, 6. This is key here, folks. Okay, and blank negative 1.5. So somewhere on this line right here, our point will lie. Okay. Now, to figure out where on that line, I'm sure there's multiple ways to go about doing this. I think what I did was this. I went and counted this length, 1, 2, 3, 4, 5, 6, 7 and a half. Okay, and this one should be the same, 2, 3, 4, 5, 6, 7 and a half. Yeah, so I've got 7.5 units right there. I don't know how many units I'm going this direction, but I do know I'm just going to throw a certain line. I'll throw it up here where it should be. Yeah, it'll end up being like right here. Okay. This needs to be, if this is a perimeter of 32, and this whole length is 15, okay, and the two leg lengths are the same, okay, what we could do is do 32 equals 15 plus x, okay? What you're going to find out is x is equal to 8.5, okay? And so if I go ahead and use that 8.5 for that length right there, we can use our Pythagorean theorem to figure out what that length is going to be, okay? So if I do this, 7.5 squared plus x squared equals 8.5 squared. If I solve for x, x is going to end up being 4, okay? And so if I move 4 units over, right now I'm at negative 3, right? Yeah, I'm at negative 3. So if I go over 4 units, 1, 2, 3, 4, that point right there, 1 comma, what was it, negative 1.5? That is going to be the location of the point of that vertex there, okay? Now I will say this, you could have gone the opposite direction as well. Most people I think go to the right, but if you go to the left 4 units, 1, 2, 3, 4, this point right here would also create an isosceles triangle. You can kind of see it there, looks like a rhombus. But that point would be negative 8 comma negative 1.5, okay? That would be the other location for that point. Either one will work when you plug it into your answer key. All right. Next one says this. Iris created a pyramid-shaped figure out of solid aluminum with the dimensions shown. Iris sells all of her figures for $6.50 per cubic inch. What is the price of this figure? Okay. So cubic tells me this is a volume formula. Volume of the pyramid is on your formula sheet. It's 1/3 times the base area times the height. Okay. Now, what's the area of the base here? Well, the area of the base, okay, is going to be 3 times 1. It's just a rectangle, 3 by 1, so it's 3. The area is just 3, and the height is 2. Okay. Now, if I work this out, 1/3 of 3 is just 1, so I'm going to end up with 2 cubic inches. Okay. Now, that's not the answer, though, because we're selling these figures for $6.50 per cubic inch. So, therefore, if I take $6.50 and multiply that by 2, it'll give me $13 is what we're going to sell this pyramid for, this aluminum pyramid. Okay. All right. Again, the formulas are on the formula sheet. Use the formula sheet. We haven't dealt a whole lot with volume or surface area, but I don't believe that they're going to give you any problem dealing with a formula that isn't already given to you on the formula sheet. A square pyramid is shown with the dimensions in centimeters. What is the volume in cubic centimeters of the pyramid? Okay, so again, volume equals 1/3 times the base area times height. What's the area of the base? Well, the area of the base would be 8 times 8, which is 64. Okay, 1/3 of 64. And the height is 9. Okay, if you plug that into your calculator, the overall volume is going to be 192 cubic centimeters. Okay, that would be the volume of that pyramid right there. All right, the next one, the volume of a cylinder is 90 cubic centimeters. Which step can be performed to find the volume of the cone with the same radius and height as the cylinder? Okay, so here's what I know. It says here the volume of a cylinder. Volume of a cylinder, I'll put CY here for cylinder, which is 1/3 pi r squared h. This is going to be 90 cubic centimeters. So I'll put it like this. This equals this. Okay. Now, I wrote that wrong. I got thinking about a cone. This is the volume of the cylinder. Okay. Now, the volume of a cone, I'll put volume CO, is 1/3 pi r squared h. Okay. So what I notice here, guys, is this, that this 90 is the same as this down here. Okay. So if I go ahead and plug in the 90 for that, I get this 1/3 of 90, which will be 30 cubic centimeters. Okay. And so up here, A, B, C, D, divide the volume of the cylinder by 3 is the same thing as multiplying by 1/3. Okay. So if you divide 90 by 3 or multiply by 1/3, you're going to get 30 cubic centimeters either way. Okay. All right. Looking at number 9, a doctor's office is deciding between buying 2 different size cups. The 2 cups are shown. Before deciding which size of cup to buy, they determine how much water each size cup can hold. How much more water in cubic inches can the larger cup hold than the smaller cup? Round your answer to the nearest 100. Okay. So here's what I'm thinking. You got these 2 cups. How much larger is the larger cup than the smaller cup? So volume of a cone, we just talked about, is 1/3 pi r squared h. Okay. So if I go ahead and do the larger cone, maybe 1/3 pi radius squared h, okay, minus the smaller cone, This right here will give us the difference between the two cones. Now, folks, I can do a lot of this in my head. A third of 6 is 2. 2 squared is 4 times 2 is 8. 8 pi minus, ooh, that one is a little harder. If I go ahead and do, in terms of pi, this is going to be 2.25. And a third of 4 is going to be 1 1/3 times 2.25 gives you 3. And so the difference is 5 pi, which is approximately, it says nearest hundredths place. Be aware of that, 15.71. Okay, 15.71 is our answer there. Now again, folks, I probably made that more difficult than what I had to. When you get to this point, just plug this all into either Desmos or your calculator. Either way, the outcome will be this right here. Okay, so just be aware of that. All right, number 10. Looking at number 10, a globe has a diameter of 12 inches. It fits inside a cube-shaped box that has a side length of 12 inches. What is the volume rounded to the nearest hundredth of cubic inch of the space inside the box that is not taken up by the globe? Okay. If you are a visual person, here's what we're looking at. Okay. We have our globe and we have this box on the outside here. Okay. And if I could, I don't know if it'd be better to do it like this. It's on the outside there. There you go. Okay. So the way I think about it is if I take the volume of the box minus volume of the cone or the sphere, that will give you your overall volume. Okay. Now the box has a volume 12 by 12 by 12. So base area times height is what they're going to tell you. Base area times height. So if you do the base area here, it's just going to be 12 by 12 times the height. Okay. The volume of the sphere, again, this formula is given to you. It'll be 4/3 pi r cubed. Okay. So if I do this, 4/3 pi. Now the radius here, if I were to do the radius, the diameter is 12, so the radius is 6. So I'm going to put down 6 cubed. Okay. And if you plug that into Desmos or your calculator, either way, you're going to get approximately, let's see here, 823.22 cubic inches. Okay. That will be your volume that we're looking at there. Again, not a hard idea. Box minus sphere gives you your overall empty space volume. All right, triangle ABC with the following characteristics is placed in the coordinate plane. Okay, AB is on a vertical line. Oh, this is the one. This is the one that we talked about. This was the challenging one. Angle C is a right angle. Point C is located at 3, 2. Over 3 up 2. Point C is right here. Okay. Point C is located at 3, 2. The slope of AC is 5. Okay. So if I go ahead and do this, slope of AC is 5. 1, 2, 3, 4, 5 over 1. I could go ahead and put A right here. Again, I could keep going up and over. Okay. I could also go down and over and place A somewhere down in here. Okay. Down this area. So angle C is a right angle. So if I go ahead and do this, I've already got this length here. Okay. That's one possibility. A right angle to that, if AC has a slope of 5, that means that CB must have a slope of -1/5. Remember that perpendicular concept. Perpendicular slopes are the opposite of reciprocals. Perpendicular slope will equal opposite reciprocals. Okay? So if I do a negative 1/5, negative 1, positive 5, 1, 2, 3, 4, 5. Somewhere on this line, okay, actually it's going to be right here. This point right here is where B is going to lie. Okay? So where is that? Well, possible coordinates. Well, we've already determined a possible coordinate for A. Again, it doesn't have to lie here. You can continue on this line up in this region up here. You can go down this direction there, okay? But a possible coordinate for A could be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we have, what did I say, 4, 7. Okay. And then for B, a possible ordered pair for B, if it's going to lie on that vertical line, here's what I'm thinking would be maybe the easiest. If you were to do point slope form, y minus y sub 1 equals m, x minus x sub 1, okay? And we already know the slope of this line is going to be negative 1/5, okay? And I know C is at 3, 2. So again, C is at 3, 2, okay? This is your x and this is your y value, so I could do y minus 3 and x minus 2. Now, that's the equation. How do I figure out where B is located? Well, I already know B has an x value of 1, 2, 3, 4. I already know it's got an x value of 4 because it's on a vertical line with A. So if I were to erase this and put 4 here, now we can go ahead and figure out what the y value is going to be. So you could do something like this. Y minus 3 equals 4 minus 2 is 2, multiplied by negative 1/5. So this would be a negative 2/5. Okay? And if you add 3 to that to get your y value, what would that be? 3 minus 2/5 would be 2 and 1/5. Okay. Oop. Minus 2/5. I don't think I did that right. 4 minus 2 is 2, multiplied by negative 1/5. So now we have a negative 2/5. If I add, oh, you know what I did? I switched the x and y value. Let's fix this. This should have been 2 and this should have been 3. Okay. So let's see how this plays out here. Glad I caught that. Minus 2. So 4 minus 3 is 1. So I get a negative 1/5 here. If I add 2 to that, there we go. Y equals a positive 1 and 4/5. And that looks better with my graph there. So I have 1 and 4/5. Okay. That was a hard one. For me, the first time I looked at that one, like I told some of the classes, I'm like, yeah, don't even try that one. That one's just out there. But now that you've seen the solution, this right here, don't forget this. I think this might be on the formula sheet, but I'm not positive, so we'll have to look at that as well. All right. Next one. What is the slope of a line that is perpendicular to the graph of y equals 5/4 x minus 3/2? Okay. Now our slope right now is 5/4, so the perpendicular slope is going to be a negative 4/5. So if I look at this right here, negative 4/5, boom, we're done. Okay. So make sure you know those basic ideas. Perpendicular lines are the opposite reciprocals of each other. Line K has a slope of negative 5. Line J is perpendicular to line K and passes through 5, 9. Create an equation for line J. Now, on my paper, I wrote down 2 different ways to solve this. You could do it with the point slope form, okay? Or you could do it with your slope and your subform, okay? It really doesn't matter here. So if we do this, line K has this slope. What's the perpendicular slope going to be? Our slope is going to have to be a negative or a positive 1/5, okay, the opposite reciprocal. So if I go ahead and plug in this point right here, 5/9, remember this is your x and this is your y, y minus 9 equals 1/5, x minus 5, okay? That would be a solution, okay? You could stop right there, be done, you don't have to go any further. Over here, you'd have to do just a little bit more work. You have your y value, you have your slope, you have your x value, and you have your b, okay? And so you would actually have to work this out to solve for b. This gives you 1. Subtract 1, you get 8. So there's your y-intercept. Y equals 1/5. X plus 8 is your answer right there, okay? Both of these lines, again, are the exact same lines. They're just different ways of writing that equation here, okay? The next one talks about a square. Well, what do we know about squares? Well, we have 4 congruent sides and we have 4 right angles, okay? So when we're looking at the slope of AB, okay, you could graph it out on graph paper and then count the rise and run, or you could do your slope formula. Now remember, your slope formula is going to be this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I could do this for AB. The slope would be this. Let's go -3 minus 2, and then 3 minus 1. What's that give me? It gives me a -5 over 2. Okay. Now, what does the slope of BC have to be? If you have AB, let's say A is here and B is here, and that's where we get the -5 over 2. For BC, it's going to have to be a positive, but the reciprocal of that. So for BC, the slope will have to be a positive 2/5. Okay. So again, understand that the opposite reciprocal slope gives you that perpendicular line. Okay. All right. Number 15, the graph of a line M is shown. What is the equation of the line that is perpendicular line that passes through 3, 2? Okay, so we're over here at 3, 2. Okay, now one way you could do this is find the slope here. 1, 2, 3, 4, 5 over 2. So this is a -5 over 2. Okay, the perpendicular to that would be 2/5. So you could do up to 1, 2, 1, 2, 3, 4, 5. Okay, but the sad part is it doesn't tell me exactly where it's crossing the y-intercept. It looks like a 1 right here, but I should probably double check. So again, you can do this in one of two ways. You can use your point slope form, and this is definitely quicker and easier by plugging in your x and your y value with your new slope. Okay, so it would be this: y minus 2 equals 2/5 x minus 3, and you're done. You could put that down, and that's your equation. Okay. Another way to do this would be using slope-intercept form. Okay. And again, I'm going to plug in my x and y values. So y is 2, the slope is 2/5, the x value is 3 plus b. Okay. Now again, this is trickier. If I go ahead and multiply these two together, I get 6/5 or 1 1/5. And if I subtract 1 1/5 from both sides, you get 4/5. So your equation would be this. That would be the same thing as that one right there. Okay. And again, you could graph that in the Desmos just to make sure that you have done it correctly. Okay. All right. The next one, Kevin asks Olivia what parallel lines are, and Olivia responds by saying they are lines that never intersect. Well, true, partially. What important piece is she missing from Olivia's response? The lines must be coplanar. Okay. Now remember, there is another term that again shows up on the air test is skew, because skew lines also never intersect, but they are non-coplanar. you go. Non-coplane lines that never intersect are called skews. So if anyone has that, easy points. Okay, probably sets the average student away from the advanced student, if you remember that right there. Okay. All right. Baseball volume, 12.75 cubic inches, and a mass of 144.585 grams. What is the density in grams per cubic inch? Okay. When they give this to you, grams per cubic inch, okay, what they want you to do is they want you to take your grams and divide it by your number of cubic inches. Okay, and if you do that, you get this, 11.34 grams per cubic inch. Okay, simple problem, don't get that wrong. Okay. In 2014, the population of Hong Kong was estimated to be approximately 7,112,688 people. The city covers an area of 426.25 square miles. What is the population and density of Hong Kong in people per square mile? So again, people per square mile. Okay. So what we're going to do is we're going to take the number of people over the number of square miles. And that should give you the population density of 16,687 people. Okay. So again, density, easy points there. We just have to know how to kind of put things together. Okay. All right. Number 19, the side lengths in units of triangle MNO are given. MN is 5, NO is 4, OM is 2.5. The triangle MNO is dilated, okay, it gets bigger or smaller by a scale factor of K, with the center point at M, okay, to create a triangle MGH. The triangle MGH has a perimeter of 17.25. What is the scale factor? Okay. So here's what I'm thinking. Since we know if we're getting bigger or smaller? Creates. Okay. We don't know if we're getting bigger or smaller, but we do know that the new triangle has this perimeter right here. Okay. So we're going to put the perimeter of MGH over the perimeter of triangle MNO. Okay, and I will tell you this, that if you work this out, this will give you your dilation or scale factor of the dilation K. Okay, so if we look, 17.25 is the perimeter of the new triangle. Okay, we don't know if it's bigger or smaller than the original one. If I add up 5, 4, and 2.5, 9, 11.5, so what this tells me is that the figure got bigger throughout the process of the dilation, okay? And if you want to leave it like this, I'm pretty sure that the air test will accept that. You don't have to finish it off. I like to go ahead and simplify it and say, hey, it's about 50% bigger than the original triangle, or 150% of the size. I would just put down 1.5, okay? So either one of those, either this fraction here or this one here, will give you that scale factor, okay? All right, to finish things off, the triangle is shown. Triangle A prime, B prime, C prime is created from ABC by a scale factor of 4. What's the length of A prime, B prime? Okay, so here's what I'm going to do. I'm going to go ahead and figure out the length of AB, and then I'm going to multiply that by 4. Okay, this is up 1, 2, 3, 4. Okay, look at that. This is a 3, 4, 5 right triangle. If you didn't know that, you could always do this. 3 squared plus 4 squared equals AB squared, and work it out, but you're going to find that AB is the length of 5. Okay. Now I also want to say this, that where do I want to go with it from there? I think I'll just leave it at that. Oh, distance formula. You could also use the distance formula here to find the distance between those two, and that's fine with me as well. You're going to get the same answer. Now, since the scale factor is 4, we're going to take that and multiply it by the original length, and that tells me that A prime B prime will have a new length of 20 units there. Okay. Whew, that's a lot. So, hey, any part of that you didn't understand, let me know. But that's a good start to our review for the air test. Thanks for listening. Bye.